Hello everyone, welcome to another video. In today's video, function part 2, we are going to discuss about exam questions of domain and range, and we are going to go through all the possible questions from domain and range finding. I hope that after today's video, you are going to have no problem at all from domain and range. Without wasting any time, let's start. So for our first question, we have a function g of x, which is x squared plus 5, and we have been asked to find domain and range of this function. Now, first of all, let's find domain d of g. So, what was domain? We talked about domain and the theory of the domain in our previous video. So, domain was whatever we can put logically as the value of the variable, right? So, what can we put logically as variable for this variable x? We can put any negative number, no problem with that one. It will be mathematically correct. We can also put 0 and we can also put positive. So, whatever we put, we are going to get a logical value from this function. So, we can put all real numbers, right? So d of g is basically all real numbers because we can put any logical values in there. But what about range? If we talked about r of g, what about range? Now, the small trick here is that whenever this kind of questions are here in our exam, what we're going to look at is the variable, this one, x squared. Now, if we can find the lowest value of the x squared, we will find our lowest value of the range. First of all, we can put anything in place of x squared, it's going to give us positive value, right? If I even put x equals minus 2, what happens is minus 2 gets squared and I get 4, positive 4, right? So it's not possible to get any negative value from here. So minus 1, minus 2, minus 3, those are out of the question. Now, what can be the lowest value then? We can put x equals 0, right? When we put x equals 0, 0 is squared and we get 0. As we cannot get any negative, the lowest value we can get is 0. So when the lowest value is 0, we have 0 plus 5, the output is 5. Okay, so this is the lowest value of your range. Now we can get 5 and we can get any values greater than 5 depending on whatever we are putting here. So 5 can be the lowest value and then we can get any positive value upwards. So our range can be from 5 to positive infinity. This can be our range. We can have 5, we can have any positive value over 5. Okay, now let's move on to our second question. As for our second question, we have a function h of x equals 10 minus x minus 1 whole square, right? So we have to find domain and range. Now what can be the domain? It's a simple question, right? We can put basically anything in there. We can put positive, we will have a logical result. We can put negative and positive 0. So we in every case we are going to get a positive possible result, right? So we can just say that domain of h is equals to real number. Again, domain can be anything that gives us a logical number, so logical answer. So we can put basically anything, positive, negative, 0, anything in there. So we are going to get a result logical number. So domain of h is r. Now let's talk about range of h. Now again, what I said is in this kind of situations, what you're going to do is you're going to look at the term with the variable. We have x minus 1 whole square, x minus 1 whole square. Now, what happens if I put any negative value of x? Let's say I'm putting minus 3. So minus 3 minus 1 whole square, that gives us minus 4 square and 16. So I'm getting a positive value, right? Now, if I put a positive value, obviously it's going to be positive. Let's see. So 2 minus 1, let's say the value of x is 2. So 2 minus 1 is 1, 1 square equals to 1. So I'm getting all positive values in case I put negative, positive, anything. Okay. So negative values is not an outcome of this term, x minus 1 whole square, right? So if I'm not getting any negative from here, I cannot make this negative positive. So if I had any negative value here, only then negative and negative becomes positive. Then 10 increases. But here the 10 is not going to increase because I cannot have any negative value in there, right? So the highest value, we understand that is 10. When I put x equals to 0, I'll have x equals to 1. 1 minus 1 whole square gives us 0 and 0 square equals to 0. So 0 is the highest possible value I can get from here. So the lowest possible value I can get from here. So it gives us 10 minus 0 equals to 10. So Can you increase over 10? We cannot, because to increase again we need a negative value there that we cannot get. So what will be range? Range will be anything from negative. As we increase any number in there for x, we keep increasing, it becomes more and more positive, and 10 minus more positive will give us negative values. And the highest will be when it becomes 0. 10 minus 0 is 0. So it's negative infinity to positive 10. We cannot get any value over 10. And as we increase the value of x, doesn't matter in negative or in positive values, the negative will be increased here, right? For example, I'm just going to give one example. Let's say I put if h of 100. What happens there? We have 10 minus 100 minus 1 whole square. So it's a big square. So obviously 10 minus big square is a big negative, right? Just like that, if you keep increasing this number in negative or in positive, it's going to be get bigger, bigger, bigger. And 10 minus a bigger number is bigger positive. So we can get any negative, and then the highest value when it becomes 0. So 10 minus 0 equals to 0. So that is our domain and that is our range. Now let's move on to question number 3. In question 3, we have another function of x equals to 2 over x minus 4. We have to find domain and range of this function. Now let's talk about the domain, d of f. Now what do we know about root overs? We know that there cannot be any negative inside the root over, right? Now what happens if I put any value lower than 4? So if I put x equals minus 3, what do I get? I get that root over minus 3 minus 4 equals to minus 7, which is actually not possible, right? It's not possible. Now let's put a positive number. Let's put 3, which is lower than 4, right? Again, I'm getting 3 minus 4, which gives us minus 1, which is again not possible. So anything that makes the inside of the root over negative, we cannot put it. So what's the lowest value we can find from here? If I put 4 in place of x, let's say x equals to 4, then I'm getting root over 4 minus 4. That gives us root over 0, which is logical, right? So 4 is the lowest value I can put in there. And if I put anything bigger than 4, no problem, we're going to get a positive number and going to get a positive outcome from this function, right? So our domain of f has to be bigger than 4 or bigger than 4. So we can just say the domain of f is 4 to positive infinity. That means we can start at 4 and we can keep increasing the number. There is no problem, but we cannot put anything below 4 because it makes our thing invalid. Now let's talk about the range of function. Okay, for range of f, what do we have here? Again, what did I say? Whenever this kind of situation arises, we always look at the term with the variable. That means x minus 4. What is the lowest outcome of this function? Now we know that the lowest value we can put for x is 4. What happens if I put 4? 4 minus 4, then root over, that gives us 0, right? If I put the lowest value here, I can get the lowest value, which is 0. We again know that the outcome can never be negative from this function because there is a root over in there. So the lowest value I'm going to get is 0. Now, what is the highest value? We can keep increasing the value of x from 4, and we're going to get positive values and more positive values every single time we increase x. So it's 0 to positive infinity. Okay, that is it for this one. Let's move on to question number 4. In question number 4, we have a fraction g of x equals to 1 divided by x plus 6. Again, we have to find domain and range. First of all, domain. What do we know about this domain of a fractional function? The denominator cannot be 0. As we have seen in our previous video, that in theory of domain and range, the denominator can never be 0 because it gives illogical output. So what makes this function 0? The denominator 0. Minus 6, right? We can find this out like this: x plus 6. If it is 0, then x will be minus 6. So if we put minus 6 in there, the denominator becomes 0 and our function becomes invalid. So domain of g can be anything, but it cannot become minus 6, right? So how can you write it? We can write it in a different way, but it's better to write that it's not equals to minus 6. That's it. So domain of g will be anything but minus 6. Okay, now let's move on to range of g. Now when we have in this kind of function, one thing is for sure, when we have 1 divided by something or any constant value like 1 2 3 4 5 6, doesn't matter what it is, we have a constant value divided by something, this kind of function can give us anything, right? If we put negative, positive, depending on negative and positive, we can get negative values, positive values, but we cannot get 0. See, doesn't matter what I put for x, this function is never going to get 0. And if we make it 0, the denominator is 0, it becomes invalid. So does not matter what value we put, we cannot just get 0 from this function, and we can get any positive, negative, or any value. So what will be the range? The range will be anything but 0. So we can write it like this: range of g is not equals to 0. So you can just write it like this and it's fine. So I think it's very straightforward. Now let's move on to question 5. Question 5, we have a modulus function. F of x equals to modulus of x minus 2, and we have to find domain and range of this function. Now, what do we know about modulus? Modulus is basically gives the absolute value of x minus 2, and the absolute value is never going to be negative. First of all, let's talk about domain of f. There's no problem putting anything for this x. There's nothing invalid, so we can just put any value for x, and obviously domain of f is a real number, right? Now let's talk about range of f. As I said, modulus gives us its absolute value, which is never negative. So let's say if I put a negative number, x equals to minus 4, what do I get from here? I have modulus of minus 4 minus 2, which gives us modulus of minus 6. And as I said, modulus is never negative, and it's the absolute value of the modulus, which is 6. So it can put at 0, doesn't matter. Again, 0 minus 2, you're getting minus 2, which will in turn become 2, right? So we can put any negative value in there, and 0 in there, and positive will obviously give us positive. We are never going to get a negative value from there. So what can be the lowest value we can get from here? We are not getting any negative. If we put x equals 2, what does it give us? 2 minus 2, which is not negative, it's 0. Okay, so the output we are getting is 0. If we put 2, then we are getting the lowest value of this one. If we put negative, still becomes positive and greater than 0. If we put positive, obviously it's going to get greater than 0, right? So range of function can be anything from 0 to positive infinity. We can start at 0 and it's going to get bigger and bigger with the values of x. It just cannot become negative. So what can you write of a range of function? 0 to positive infinity. Again, what modulus does is give the absolute value, and the absolute value is never negative. Now let's move on to question 6. So in our question 6, we have another function g of x equals to 5 minus modulus of x plus 1. Now we have to find domain of g and range of g. Now let's talk about the domain first, domain of g. Now we can clearly see that we can put literally any value there, negative, positive, 0, anything. So obviously the domain will be a real number. Now let's talk about range of g. In our previous math, we have seen that modulus can give us the highest value of 0. Whatever we put there, if it becomes negative, for an absolute value, it's going to be positive. So the highest value we can get from this term is 0. Now that gives us 5 minus 0 equals to 5 as the highest possible value from g of x. Because if we want to increase the value, then we need a negative there to make it negative, negative, positive. Then only then we can increase the value of 5. But we get the highest value from this term as 0. So we cannot increase 5. The value is always going to get lower than 5. 5 and lower than 5. When it's 0, we get 5 minus 0, then 5. 5 is included, but we cannot get higher than 5. So the range is obviously is going to be negative infinity to positive 5. As we increase this term, then 5 is going to get negative, bigger and bigger negative every single time. So we can get minus infinity to 5. That's it for this one. Now let's move on to question number 7. Now in question 7, we have a question h of x equals to root over 16 minus x squared. We have to find the domain and the range. Now first of all, let's start putting values here, positive and negative and 0, and let's see the outcome. Let's say we are putting values of negative. Let's say x equals to minus 5. If I put minus 5, what I'm getting from h of x gives us root over 16 minus 5 square will give us 25. so which is minus 19, which is not possible, so it's illogical, so you cannot take it. Now if I put x equals, let's say, minus 4, that gives us h of x equals to 16 minus 16, which is 0. Now let's put minus 3. We have a value here, h of x equals to, we'll have 16 minus 9, which gives us root over 7, which is acceptable, obviously. Now we have x equals minus 2, so we get h of x equals 16 minus 4, which gives us root over 12. Just like that, when I put x equals minus 1, I have h of x equals 16 minus 1, which gives us root over 15. Now let's put x equals to 0. If I put 0, I'm getting h of 0 equals to root over 16. That gives us 4, right? Okay. Now if I repeat it with positive numbers, that means positive 5, positive 4, positive 3, 2, 1, this is going to be the same thing for them, because if I put negative 5, I still get 25. If I put positive 5, that's 25. So the highest possible value I can put here is anything greater than minus 5. Anything greater than minus 5. I can put minus 4, get a logical value, minus 3 logical value. But whenever I'm putting value more than minus 4, this is getting bigger than 16. When it gets bigger than, when square gets bigger than 16, I have a negative value inside the bracket, which is illogical. So I can put values in between them, but I cannot put minus 5 or plus 5. If I put plus 5, plus 4, plus 3, plus 2, plus 1, and 0, it's the same thing again, right? So we cannot put anything over minus 4 and over plus 4. If I put anything over minus 4, it gets negative. If I put anything over plus 4, it also gets negative, right? So what will be our domain? So in this case, what I can say is the domain of h, that means d of h, will be anything below minus 4 and plus 4. I cannot go beyond minus 4, I cannot go beyond plus 4. So I can just write it like this. Minus 4 will be the lowest value here, right? We cannot go lower than minus 4. Minus 4 is domain of h of 4. That means the domain has to be minus 4 or greater, but also with the same time plus 4 or smaller. Other than that, whatever I put in there, it's going to give me an invalid value. Now let's see the range. So depending on these outcomes, I'm not going to erase the outcomes. Let's keep the outcomes here for the values. So depending on these outcomes, what is the lowest value I'm getting here? The lowest value I can get from here is again 0. I cannot get any negative. I can put anything in there. The lowest value I'm getting is 0. If I put x equals to minus 4 or plus 4, any one of them, I'm getting 16 minus 16 root over, right? Which gives me 0. But can I get lower than that? I cannot get lower than that. But what is the highest value I can get from here? Now, the lowest value of x will give me the highest value, right? Minus 4. If I put minus 4, it gives us me 0. Now, our range was minus 4, minus 3, minus 2, minus 1. We can put all of them, the domains. Then we can put 0, 1, 2, 3, 4. So these are the all of the values that we can actually put as domain, right? That is it, minus 4 to plus 4. But when I put 0 in there, what do I get? If I put x equals to 0, then I'm getting h of x equals 16 minus 0 square is 0, right? So 4. Can you in any way get a value greater than 4? Is it possible to get a value greater than 4? Whatever you put these values, if you put 1, it's going to get reduced. It's going to come down less than 4, right? So does not matter whichever value you put other than 0, you're going to get a value lower than 4, right? So the highest possible value from h of x is 4, and the lowest possible value from h of x is obviously 0. So if I write range of h, it will be from 0 to plus 4, right? We can always get a value from 0 to plus 4, but not lower than 0. Obviously, negative cannot be inside the bracket, inside the root over. And also, putting any values in there, 0 gives us the biggest value, which is 4. Now, these are only the domains of this function. Now, let's move on to question 8. So, in our question number 8, we have f of x equals to 3 divided by root over x minus 5. Now, let's find the domain first. So, d of f. Now we have a fraction. First of all, we have to consider something that we cannot use as a domain, which makes our denominator 0. What is that value? 5, right? If we put 5, 5 minus 5 becomes 0, and this gives us an invalid result for function of x, so which is not part of the domain. So we cannot put 5. Now, because of the root over, we have another condition. We cannot make this one negative. That means we cannot put anything below 5 in there. If I put 4, 4 minus 5 becomes minus 1. So root over minus 1, which is not possible, right? So we have to consider two things here. First of all, we cannot put 5 because this makes the denominator 0. And then we cannot put anything below 5, which makes the denominator root over minus something, which is not possible. So the value of x must be bigger than 5, not even 5, because 5 makes it 0. So the value of x must be bigger than 5. So any value bigger than 5 here is a feasible value. So that is our domain. So for this domain, we can write domain of f is x is greater than 5. Remember, not equals, because you cannot put 5. X is greater than 5. That's our domain. Now let's find range. Again, as we have already talked about it, in this formation, we can never get a 0 from this function. Never get a 0, because we have a constant in there and we cannot have a 0 in there. Okay, so 0 is not part of the domain. Now again, we cannot also get negative, because it can only be negative if this root over something gives us a negative, right? If we divide 3 by a negative number, only then we can get a negative. But from this root over, we are not going to get any negative. So the output is never going to be negative. And also the output is never going to be 0. So range of f is anything greater than 0. So that's it. I hope it's very clear. Now let's move on to question number 9. In question 9, we have h of x equals to 12 divided by x squared plus 3. Now, for the domain of this function, we can basically put anything in there. Because of the square, it's going to be a positive value, and there is a plus 3 in there, so the denominator is never going to be 0. So we can basically put anything in there. So the domain is real number. Now let's talk about the range. Now, as we have talked again, this formation never gives us 0. So 0 is not part of the range. Now let's talk about the highest possible value from this fraction. When the denominator is the lowest, the value is the highest, right? When the denominator is the lowest, the value is the highest. What is the lowest possible denominator from this function? If we put x equals to 0, then 0 square is 0, 0 plus 3 gives us 3, which is 4. Now this is the lowest denominator possible. We cannot get a lower denominator for this one, because if we want anything lower than 3, we need negative something. And square is never going to get us negative something, right? So 3 is not going to get lower. This is the lowest possible denominator. And for the lowest possible denominator, we get the highest possible result from a fraction, right? So the result is 4. So 4 is the highest possible result from this function. So this one. Now, starting from what? As we know, x square will never give us negative. So we are never going to get any negative number from this one, because 12 divided by a positive number is always going to be a positive number, right? So it's not going to be 0, and it's also not going to be negative. So it's bigger than 0 and highest is 4. We can get 4 and lower than 4, but it has to be bigger than 0. So we can just write it like this. 0, our range will be greater than 0, but equal or less than 4. So this is how we can find the range and domain of this kind of functions. Now let's move on to the last question, question number 10. In question 10, we have function of x equals to root over x minus 3. Now, it's very straightforward. Domain of f, we cannot put any negative number in there. We know that. Inside the root over, we are not getting any negative. So we can put 0 and any positive number. So domain of f is going to be 0 to positive infinity. We can put any positive number in there. Now let's talk about the range. What is the lowest possible value we can get from the root over x term? We know that we cannot get any negative, because whatever we put inside, we are always going to get a positive result. The lowest we can get from here is 0. When you put 0, root over 0, which is 0 minus 3, it gives you minus 3. So it is not possible to get a value lower than minus 3. If we want a value lower than minus 3, we will need a negative here. That is not possible because of the root over, right? So the lowest possible value we can get from here is minus 3. Now, as we increase value of x from 0, it's going to get increased, and it can go to positive infinity. We can get a very big positive number, minus 3, it's still positive. So our range is going to be minus 3 to positive infinity. So that's everything about domain and range of a function, and I hope that you are not going to have any more problem with finding domain and range of any function. If you like the video, then please subscribe my channel, and in our next video we're going to talk about inverse function. Until then, bye bye.